Alrighty, I see some folks joining now. Hello, welcome. We're going to give everyone a couple minutes here to join. So let's wait for a minute or so here before we get rolling. Welcome everybody. Yeah, it looks like we got a good amount of people joining now. We're just going to wait another minute or so. Alrighty, let's get started. Welcome to the webinar. Yeah, I'm excited to host this one. My name is Roy Kincaid. I'm a solutions architect here with Soracom, and we'll be covering getting started with Soracom today. So yeah, you can reach me on Twitter at RoyCodes, and you can also use the hashtag Soracom to talk with us too. So just a couple items before we get started here. You are all muted, so I can't hear anybody. But if you have any questions or if there's anything that I'm not covering, please use the QA button that's in this video to leave your questions, and then we're going to have some time at the end here. So we're going to do about 30 minutes of covering some things, and I'll show an agenda in just a sec. But yeah, please put your questions in there, and then we'll get to them towards the end. Alrighty, so here's the agenda that we're going to cover today. We're going to start with just an overview of Soracom, and then we're going to cover our Soracom user console and our just a high-level overview of our APIs. And then while we're in there, we're also going to show off some of our platform services. So we'll actually get our hands dirty a little bit and hop into a Raspberry Pi just so you can get a sense of what some of this actually means in real life. And after that, we're going to look at a couple case studies of some of our customers who are currently using these services in production and how it's benefited their particular use cases and where they've realized some value there. And then at the end, I'm going to show a slide. We're launching today a new IoT consultation. So if you like what you're hearing and you want to talk to us more about your project and how we can collaborate on things, please fill out that form, and I'll have a link to it as well at the end. Oh, that's another good thing to mention is that all of these slides will be available after this webinar as well. So we'll get that out to you, and we'll also get you a link for this IoT consultation that you can sign up for, so we can continue working together. And then at the end, we'll have time for Q&A. So please get your questions in. I'm also going to launch a poll right now. So please feel free to vote on this poll here. The question is, what phase is your project currently in? So I've just launched that, and hopefully that's popped up for you guys. So yeah, let's move forward. Alrighty, so let's just frame things a little bit. Traditionally, if you think of the Internet of Things and IoT, you have this mental model in your head of the things or devices over here on the left that are connected via the internet back to your cloud environment, right? So over here we have the back end, and on the left we've got the things. So in this traditional paradigm, the things or devices themselves are on the hook for making sure that they're speaking encrypted protocols, and they're managing those endpoints that live in the cloud. So that way, when they're communicating over the public internet, they've got a nice secure channel back to your infrastructure. So again, that's going right from these things over the public internet back to your cloud environment. And then typically with other connectivity providers or with other means of connectivity, this is kind of the mental model that we're all really familiar with. What I'm here to show you today is how Soracom kind of flips this on its head. So here is that same concept, but with Soracom. And as you can see here, just at a super high level, that we, since we're sitting in here on the cloud side as well, we can actually completely make the public internet part of this flow optional. So it's still there, it's still available to you. If you're using our connectivity solutions, you can still, of course, have access to any public endpoints, just like you can with any other type of connection. But really, we're going to cover the secret sauce in here, which is being able to leverage these Soracom services that live inside of our special infrastructure, which mean that you don't actually have to traverse the public internet if you don't need to for your use case. So let's go over a couple of the high level benefits of using Soracom. So one is security. So like I was just saying, you're able to manage those endpoints in your cloud environment. You're able to manage your credentials and API keys all securely through Soracom, and that allows you to still leverage that security, but offload it from your devices. That way, they're not on the hook for managing that overhead of creating that connection, sending that extra data over via cellular in terms of just the headers that are in those packets that enable that encryption. And you also, if you have a device that maybe is battery constrained, that also can help in that scenario as well. In terms of our billing structure, we're pay as you go with no commitments. So you may be familiar with other more traditional ways of paying for connectivity, where you've got these big commitments, you've got pools, you've got fees for going over or going under certain thresholds. So with Soracom, it's all, none of that really exists in our system. The way we do it is it's a very clear and transparent pay-as-you-go model. So you're paying for what you're consuming. And we provide all of that information to you so that you can then go ahead and figure out ways to bill your end customers. So by giving you all of these tools and all of this visibility and granularity into your bills, it kind of enables you to become your own connectivity solution as well, because you have a better idea of what to charge your customers. And again, we have no commitments. In terms of scalability, a big thing there is that you can just buy SIMs right from our console. So you can click a button and start buying SIMs. You can buy one SIM, you can buy 100 SIMs. You don't need to get on the phone with somebody. You don't need to wait for some ink to dry and some paperwork. When you're ready to get some more SIMs, you click a button and they're on their way to you. And availability. So availability is a big thing for us in terms of our actual infrastructure, which I'll go over in a second, and just the part of our infrastructure that's built inside AWS is built to AWS best practices. So you have the high availability and redundancy there. But also in terms of availability, I like to consider your actual devices that are deployed in the field. So one thing with using a global connectivity provider like us is that in a lot of countries that we operate in, we'll have redundant coverage on multiple carriers. So for example, in the US, our connectivity, our cellular connectivity can roam on top of AT&T and T-Mobile. And what that means is that inside your device, if you have a modem that can support either or AT&T or T-Mobile, our SIM card will allow that device to connect. So you've got that availability there. And then we've got manageability. So this really comes into play when you're talking about scale. So when you've got 10 or 100 devices, you can use the dashboard, you can use the GUI, but once you're past that, then tricks to operationalize certain workflows and leverage automation and leverage our APIs is really where we see a lot of customers get the most value out of our platform, because we provide you with all of those tools. That way you're able to automate a lot of workflows and manage your endpoints better. So we won't spend too much time on this one, but this is just a high-level overview of how our architecture sits today. So what happens is over here, we've got your devices, and then they connect over LTE or 3G over base stations through carriers. So in the US, again, that's AT&T and T-Mobile. And this would be a good time to mention that we support over 130 countries globally and over 200 carriers. So that's the same SIM card for all of those. So you have that one SIM card, and you can deploy your project globally, depending on the details of the specific modem that's in your device. But we can talk about that more as well. So then from there, it goes right into our private infrastructure, Soracom infrastructure inside AWS. So we get to create this completely secure and closed channel from your device over to Soracom. And then with Soracom sitting in the middle between your devices and your cloud, that's why we're able to leverage a lot of these tools that we're going to be talking about today, where you put the burden on Soracom to do some of that overhead and manage some of that processing. That way your devices don't have to do it. And in this example over here on the right, we can see some of the AWS services. This is just a fraction of the ones that we work with. But we're also agnostic of the cloud environment as well. So if you've got endpoints that are in Google or Azure or in your own custom data center or on-prem, that part doesn't really matter from the Soracom's perspective. We can make that work. And then one key thing to note here is look how far over we get in this chain before the public internet is even a factor. It's all the way over here on the right. So what that means is that in certain cases, like this one here, so this VPC peering, this all can happen before the public internet is even a factor, and that lets you build a completely private, basically a giant LAN between your devices that are out in the field and your server endpoint. So they can both talk to each other over the private IPs instead of having to talk to the public internet at all. So especially just in terms of security, if you follow a lot of like IoT related headlines, there's always there's a deep concern in our industry about devices accessing the public internet. So for those use cases, we have that option. Now, because Soracom sits in this layer and we do have some of these features, I wanted to show you this overview of our services, right? So down here at the very base level of our stack, we've got our connectivity. So this covers our cellular connectivity like 2G, 3G, 4G, et cetera, LTE-M, which is a newer technology built on LTE. But we also support low power wide area networks such as Sigfox and LoRaWAN. So we put all of that into our connectivity layer at the bottom of the stack. Then on top of that, we get into networking. And this is where, like I was mentioning before, you have the ability to create a peered network between your backend environment and your environment within Soracom. So in Soracom, we have a product called VPG, or Virtual Private Gateway, which lets you build your own isolated area within Soracom that you can set your own CIDRs for and assign private IP addresses to your devices. And then from that VPC, we then have different products that let you link that back to different environments. So if you're in AWS, you can use Canal and use the VPC peering. If you're in a different cloud provider, we can do VPN to that cloud. And the cool thing about that is if you think about like a traditional VPN deployment, the VPN client needs to be running back on those devices. But because of the way that we're built, the actual device doesn't even need to really worry about that part. That's all done on the Soracom side again. So then once we're outside of the networking services, then we're into the application services. And we're going to be looking at a couple of these today. What these let you do is, again, offload some of that overhead from your devices. So some examples are Beam. Beam lets you, if your devices are speaking some lower level protocols like just raw TCP or UDP, you can basically send that data straight to Beam, and then Beam will convert it into whichever secure protocols need to traverse the public internet to the final destination. So it's sitting there like a middleman, and you can have a device sending data to it, and then it's taking it and it's controlling where the final destination is and what final protocol it needs to be in, and it's doing that conversion for you. And we'll go over some use cases of some customers that are doing some pretty interesting things with that. Funnel is similar. It's just helping you stream that data and get it into services such as like through Kinesis, AWS Kinesis into an S3 bucket. And then Funk is our newest one, and this is very cool because you can actually trigger serverless functions like a Lambda function directly from your device and get that response back on the device as well. And this way, your device doesn't need to worry about configuring the AWS SDK or anything like that. from the device side, it's still just sending that data to Soracom, and it doesn't need to concern itself with where it's actually ending up. And then in terms of BI tools and data visualization, we have Harvest and Lagoon. So those are two that we're going to dive into in a second. So I'll save those right now. And then on top of that, we just have our interface, which we're going to jump into in a couple seconds here. So that's our user console for web-based management. All of the APIs that we expose for our customers, and then access management and SDK. So let's hop over into the user console, and we can start looking at a handful of these. So we definitely don't have time to dive into the majority of these. I'm just going to pick a couple now to look at. And then if you have any questions about some of these, or you're interested in learning more, please, if you have the question, please put it in the QA box now. Otherwise, please fill out that consultation field that we'll talk about in a sec. So let's hop over to the actual user console now. So here's the Soracom user console. So this is your cockpit or your dashboard for managing all of your SIMs. So every time you purchase SIMs, which you could do by hitting menu and then order. Once you order SIM cards, they show up. They just show up right here in this table in ready state. So this will show you the current status of that SIM card. Once you start using it, it'll flip over to active. And then in this column, we see if the device that SIM card's in has created a data session and it has access to the internet. So that's what we're seeing here. And then a couple other quick things to note here is that we have this IMEI lock feature. So an IMEI is a unique identifier that lives inside the modem that's inside your device. So it's kind of like a VIN number or a MAC address. And what you can do with this lock is, let's say a bad actor were to rip the SIM card out of your device. You can set this and configure it in a way where that SIM card will only work with the device that it's currently in. So other things you can do, especially at scale, it's important to name and tag and group your SIM cards. Let's say you can have groups for like different stages in your production flow. You could have groups for different end customers. So that's the grouping here. And then also down here, we'll give you a map. And this is a coverage map of where your devices are currently located. And this pin here is based on the actual cell ID that your device is reporting back to us. So we'll take a look at that, what that looks like here. So if we take a look at this particular device, so you can see I've named this Raspberry Pi because it's in a Raspberry Pi that's on my desk at the moment. And I've got it in this webinar group. If we click up into details, we can get some more information here. So we can see the current IP address that Soracom has given it. We can hop over into historical charts, and we can take a look at the actual data consumption that's going on that device. And we can break that down into different periods here. We also have this watch service set up, so you can automate some alerting when if the SIM is if it's exceeding certain thresholds, you can trigger an email, or you can even narrow the throughput and slow it down while you're troubleshooting and trying to figure out what's going on with that particular SIM card. And then here's session details. So we'll give you all the logs in here of every time that device has created a data session. So you can see the operator that it's roaming on, the radio type, all the way down to the actual cell tower that it's communicating with. So all of those logs, excuse me, will show up in here. And that cell ID is what we're using to populate that map. All right, so let's talk about groups for a second. So once we've got our SIMs into different groups, and here is where we can toggle on or off different Soracom services for that group. So for example, here's Beam that we were talking about a moment ago. So in Beam, if I hit this plus button, you can see on the left, on the left side are the protocols that may be coming off of my device. So let's say my device is speaking MQTT, for example. So from the device side, all it needs to do is send MQTT to Beam. And then in here is where you manage the final destination. So for example, if it's in Google or Azure, or if you want to put a AWS IoT Core endpoint in here, the final destination is all configured through here. So you can see, like, once it's actually in Soracom, it needs to traverse over the public internet. We can flip it to MQTTS so it's secure. We can manage our endpoint here. We can upload our credential sets here, and then we're off to the races. So a cool thing about this is that in 6 months from now, for example, if you had to change a credential set or update this endpoint, instead of going down and changing any code or making any firmware revisions on the devices themselves, you can actually just hop in here and do it for the entire group, because the device doesn't really care about that part. It's still just going to be plugging away and sending that same data to Beam. So there's a major convenience factor in managing that final destination and managing those credentials off of the device. Another thing to note is that those packets are going to be smaller too. So when it's going over cellular, it's MQTT, and then once it's in Soracom and it's just going over the internet, then it's MQTTS. So you're not paying the cellular difference between these two, because that's happening off after the cellular part. Alrighty, so that's Beam, and then Harvest, which I'm going to show you in a second here. What Harvest does, it's our data visualization platform. So if you've got this turned on, what we'll do is we'll also be looking at that data and building some charting for you, and also storing it so you can see the raw data as well. So if you choose to turn this on, then you've got access to that as well. And let's say, for example, you want to use several of these. So you've got you're sending data via MQTT to somewhere, and you're using Beam. And then it's going into an S3 bucket for some other workflow. So you're using Funnel. And then you've got Harvest turned on, so you can build your dashboards. Instead of having to send that same packet 3 times, you can send it to our unified endpoint. So what this will do is you send it once here, and then it will go ahead and fork it off to all the different places that you've configured up here. Alrighty, so let's go back to our SIM management console. I want to show you one of our newest features called Napter. And what that lets you do is it's for on-demand remote access. So instead of traditionally having, let's say, like a static public IP address that's available 24/7 over the public internet, which puts you on the hook for hardening it and making sure that it's secure, what we have as a solution to that is Soracom Napter. And then this lets you create on-demand remote access, so ephemeral endpoints that you can use to temporarily gain access to one of your devices, and then it can disappear once you're done. So in here from the GUI, we can set it up for a different time range. And by default, it's going to only whitelist my current IP address to access that device. So in this example, we're going to be SSHing into that Raspberry Pi that's on my desk. So I'm exposing port 22 here for SSH. Now, another thing to note here is that on the Pi itself, there's no user agent or any Napter application or any software stack running on it. As long as it just has standard SSH configured with 22 open, then this will work, because the networking side of this is happening on the Soracom side. So once I've created this endpoint here, you can see that it's generated this for me. So I'm going to hop over to terminal window here, and hopefully that's not too small. I'm just going to go change my username to Pi. And while that's going, I'm going to move this over here. Alrighty. All right, so now completely over cellular, we have SSH'd into that Raspberry Pi that's sitting on my desk. Now on here, I've got this little Python script called telemetry, and all that's doing is sending some basic JSON over HTTP. So not HTTPS, it's just sending that basic JSON off to Soracom. So we're going to just start that running right now. Okay, so as we can see, I'm just printing that JSON to the screen as well so you can see, but I'm just sending a timestamp and temperature, humidity, and a latitude and longitude. So this is being sent up to a Soracom endpoint over basic HTTP. So now that that's happening, let's go back over here and I'll show you what harvest looks like. So we've got that sim selected, I'm going to go over here and click harvest data. I'm going to turn on this auto refresh. And now we can see that this data is coming in off of the device. And so we'll try to graph it for you up here. And also if you scroll down, you can also see the raw data here as well. This is, besides just the data visualization, this is really, really good for troubleshooting as well, because once you've got that connectivity, you can just turn on harvest and just use it as a sanity check just to make sure that your device is sending that data correctly. So it just helps you pinpoint where you might have an issue. So when you're building POCs and testing some things, harvest can be really helpful in that regard as well. So what if you wanted to take this up to another level and you want to build out some more complex dashboards and you only want to give them to certain people in your company? Like maybe like a BIE or somebody just needs to have some tool that they can use to leverage this. Well, we've got a service called Lagoon here, which I am opening now. So in Lagoon, you have your own area here where you can manage your users and create them. So once you've got them created, we can launch the console. And this way you can keep them separate from the actual SIM management. So this is all built on top of Grafana, if you're familiar. And let's just go and create a quick dashboard here. So let's create a new dashboard, and let's say we just want to build a graph. So we'll hop into there and edit it. As you can see down here for my metrics, these are the different SIMs that are reporting data to Harvest in my account. So I can flip right over to that Raspberry Pi that we were just looking at. And I could say, okay, it's already picked up the different JSON key value pairs. So all the keys are in here. I say, I'm going to pick humidity for this example. And then we can see that it's still coming in over there. And let's just call that humidity. And there we go. And then we can set this down to like the last 5 minutes. And that's how easy it is to quickly build out some dashboards. See, we'll add one more for fun. We can add a table here, edit that. Metrics. Let's say we just want a table that's going to show us everything. There we go. And then we can go back, and now we've got this table. We can drag and drop them around. We can add maps, etc. And then we can share these with people inside our organization. Great. Okay, so we're running out of time here, so I'm going to flip back over to PowerPoint, and we're gonna quickly take a look at some use cases, some case studies. So here's an overview of some of the customers and partners that we work with around the world. So we are a global company. We're headquartered in Japan, and we're expanding rapidly globally too. So you'll see a lot of enterprise and startup logos from all around the globe here. And let's just dig into a couple that are doing some interesting things with our services. So Pebblebee, they make this asset tracker that you see here in this photo. And what they've done is they're using Cat M1, which if you've heard of Cat M, it's kind of one of the new IoT cellular technologies. So it has a lot of built-in benefits for battery-constrained use cases. So one of them being EDRX power saving mode. So what that lets you do is actually put the modem to sleep for a certain time window. That way it's not consuming battery. And then it can then wake up and send data out. So what Pebblebee has done is they've built their architecture within a VPC that's in AWS. And they're using Canal to basically make a giant LAN between these devices and their AWS environment. And what that lets them do is reach down and directly connect to those devices through their cloud without having to touch the public internet. So Yeah, that's this one here. And then Daido. So this is one of the largest vending machine companies in Japan. And they use Soracom services to send the data from their vending machines over via Soracom funnel into Kinesis, and then it ends up in their S3 bucket. So what this lets them do is offload the need to have certificates on each one of those machines. So in terms of just their general workflow, this really helps them get those machines deployed into where they need to be, and cuts down on the amount of operational overhead it would take to send technicians out and get these certs loaded up onto the machines and that type of thing, as well as saving the amount of overhead it would take to send that data over the public internet in in a traditional fashion. And then last one here is Will. So they make these electric mobility scooters, and they noticed that once they started using Beam to fall back to some older unencrypted protocols, that they saw a 30% reduction in the power usage on their devices. So what they're able to do is these devices can speak just TCP or UDP up to Soracom, and then we can then convert that into HTTPS, so an API call for them, and then make the API come back and then go back to the device. So that way, the device doesn't need to manage that overhead of HTTPS, and they can still get that information back into their REST APIs. Alrighty, so that was the last case study here. I see that we're at the half-hour mark, so I'm just going to hop over to Q&A here and take a look at some of these. So yeah, please, if you have any questions and you haven't had a chance, looks like we've got a good amount in here now, but please post them in here. Let's see. Okay, so here's a good question. What if my MQTT backend is not inside AWS? Yes, so we're cloud agnostic in that sense. So yes, our services are quite transparent in that regard, and we've got some built-in templating for your more common cloud-based solutions, and then you can also manually configure them as well. Let's see, we've got one here about the Raspberry Pi networking. Let's see, PPP link. So yeah, on the Raspberry Pis, when you're managing that cellular connection, there's a couple different ways you can do it. So you've got, if you can take a look at we have a Raspberry Pi starter kit, and we've got a good getting started documentation for that. And inside of that getting started guide, there's a setup script that helps you just bootstrap the cellular connection. And part of that is by using a software package in Linux called Modem Manager. And that's really convenient, especially when you're just getting started and you've got a Linux-based device, because it has a really wide range of compatibility across different modems. So once you've got that up and running, there's a good chance that it'll auto-recognize your modem, and that helps you get started. Other alternatives to that are WV-dial, which will let you manually configure and initiate that connection. And then at the very base level, you can use PPPD and do it in a more manual fashion. Okay, so we have a question here about the latitude and longitude. Right, so in that example that I was showing, I was just manually entering the latitude and longitude. If you have a device that is grabbing that over GPS, then you can report that back into our systems or back wherever it needs to go. And you can even go into Harvest and set those key value pairs just so it knows if they're named something other than latitude and longitude, or yeah, if they've got some goofy syntax for that, you can set those as well, so the system will pick up on that. And then in Harvest, you can click on a map, and then you'll see that latitude and longitude there. In terms of the overall map that I was showing on the main dashboard, that's just the pin on that map is coming off of the cell ID, so that's directly off of the SIM. So there's no latitude and longitude coming off of the SIM in that regard. let's see. Can I get latitude and longitude from the sim? So yeah, so that would depend on the the cellular module that you're using. So there are some modules that have built-in GNSS, and if you're using one of those, then you can certainly grab that off of the module and report it back. Or if you're using a secondary, like a module that's just for GPS, and yeah, report that back in your payload. So we have a question about Raspberry versus other devices. So in the IoT world, we're really seeing there's really two different ways to go, and it really depends on your use case. You either have your single board computers, like a Linux-based Raspberry Pi or something like that, and then you've also got like the microcontroller realm of things. And that really depends on how complex your application is, and also form factor can be a consideration there. Microcontrollers can get really small. They're definitely a lot cheaper. And there's also another factor where you've got UART, or you're talking just right over serial on those microcontrollers to those modems. So that's another thing to consider as well, where on Linux, you can also do it that way, but you also have the ease of use with like with using USB. Okay, where can I buy your SIM cards? That's a great question. So right in our, right from our user console, actually, you can hit that button and you can purchase SIM cards right from there. Another good thing about that too is that they'll show up in your account in that ready state. So you already have a heads up of the SIM cards in there. So you don't have to go in and then manually type in each one to get them registered. Okay, so got a request to, oh, okay. So in terms of the slides, yes, we're gonna make them all available after this webinar. So you'll be able to grab all of them after there. So let's see, we'll go back to architecture. There we go. Is it possible to use a regular cell phone as a gateway? Sure, yeah, it's totally possible to do that. Yeah, so the other, that's a good point actually. So we've got our single board computers, right? Then we've got our microcontrollers, but we also have cellular gateways, right? Which are more like just routers that have that cellular connection. So you could definitely use a phone in a pinch to configure something like that. I was actually looking at the that Pine phone that recently came out, because that has a global Quectel modem built right into it. It's only like $150 for the whole package, and it seems like it could be a pretty cool prototyping device. The only thing to consider there is that you don't have the GPIO that you would with like a Raspberry Pi if you're using a phone. So you're going to be using like Bluetooth or yeah, BLE or something else to get that sensor data back through your system. And if that's something that you're interested in, please let me show you this. Yes, I totally forgot to show you folks this. So this is our new IoT consultation page. So please, after this webinar, if you're interested in talking, go fill out some details here, and Soracom will be in touch with you to set up a call so we can deep dive into your specific use case and start working. Okay, so we have a question about global coverage. So let me show you folks that quickly here. We go over to our documentation. Just hop in somewhere. If I go down here to quick reference and I click on supported carriers, here we see the full global list. Here are all the different carriers globally that we support. And then over here on this side, you get to see the actual, yeah, here are the carriers on the right. And then on the very far right, we have, excuse me, the specific technologies that they support. So we had a question here about Verizon coverage for LTE-M. Currently at the moment, we do not support Verizon, but it's something that we're working on. So we hope to have news on that in the future. Let's see, what else do we have? LTE-M coverage in Canada. So that's a great question. So we don't have official coverage with LTE-M in Canada. However, since it's built on top of LTE, the modems are going to be able to connect. So I was up there a while back testing an asset tracker and going all around. And since we support all of the 4 major carriers in Canada, I was able to get that device connected over LTE-M to all 4. A big thing to note about LTE-M coverage globally is that there's a couple other considerations too. You want that connectivity, and most of the time, that as long as LTE is available and the coverage is the LTE-M coverage is available, then that'll connect. But also EDRX and PSM are those battery saving modes, and that's another thing to consider as well. So if you're going to be utilizing those, you want to make sure that the module you're using and the carrier that it's going to be roaming on are going to be able to both support those technologies as well. Okay, how can I access the information in my own backend? Sure. So that's a good thing to mention regarding our API. So if we go back to this user console, I'd like to mention that every single button, every single feature that you see here, this was all built using our publicly available APIs. So if you are building your own admin panels or internal dashboards, or maybe your own panels for your end customers, you can pull in all of our APIs to build any of these features or functions into your own console. See, we got lots of questions. That's great. Okay, we've got another one on modem compatibility. So yeah, modem-wise, Soracom is agnostic. So we're kind of sitting in the middle, and one of the big things for us is trying to keep out of your hair on the device side and also the cloud side. So with modems, there are certain ones that we see that work better with certain carriers in certain countries, and that type of information, if you're interested in maybe getting a recommendation or a short list of here are the specific like makes and models and the pros and cons of using one over the other, we can totally dig into that during a consultation. And it also really depends on your specific use case too. Even down to the cellular technology, right? So CAT-M is very new. You've got 2G and 3G. It's been around forever, but in the US, it's all being sunset, right? So the window for using those is closing fairly rapidly, and then 4G as well. So there's a lot of things to consider in terms of cellular technology and the specific modem you're using and the bands that modem supports. So if you have any questions about that for your specific project, I'd be happy to dig through it together. Okay, we have one about data collection. So if there's a concern about the data living at rest within Soracom, then you can just choose not to use Harvest and keep that off, and then you can have that data flow into any endpoint, into any endpoint that you want into your own backend and store it there, and then build your own data visualization layer on top of that data. That's totally cool. Let's see. Okay, we have a question about the actual setup on my Pi. So if you take a look at let's go back to the developer docs, which are awesome. This is just a great tool. We go over to guides. We go down to our Raspberry. So we sell this Raspberry Pi kit here. And with this kit, you have an ultrasonic sensor, so that measures distance. And then you get a Raspberry Pi Zero. You also get a dongle, a cellular dongle. And then we've got a setup script down here that you can run. And then basically what that does is it installs Modem Manager. It gets your route set up. That way, if you do have Wi-Fi connectivity on the Pi, it'll only be sending, it'll set up some routes. That way, any data that you're sending to Soracom, it'll route it over cellular, and anything you're doing while you're testing, like if you're just doing an apt-get or installing some packages or something like that, it'll keep doing that over Wi-Fi. That way you're not paying for pulling that type of data. So it sets up those types of routes. It sets up Modem Manager. It configures the profile inside Network Manager, which is where the connection actually gets going. And in there, you can see, besides that, rules-wise, all I did was add that SSH file, because I'm running the Pi headless. So when you install it, when you first flash your SD card, you can copy over 2 files, one being just a blank SSH file, and that enables SSH, and then another one, WPA supplicant.conf file, which is what you use to set up your Wi-Fi credentials. And okay, that's it. That's all we got time for here. I'm really sorry if I missed your question, but yeah, again, thank you so much for joining me today, and I will follow up with you folks with all the information that we went over today. And yeah, thanks again. Take care.